Hi, in this video, I am going to take 5 questions from class 10 NCERT science textbook. The first question is from the chapter electricity. The first question is an electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat developed in 30 seconds. So here the electric iron offers a resistance of 20 ohm to the flow of current, and the current that is passing through this iron is 5 ampere. So we have to calculate what will be the amount of heat developed for in 30 seconds. Now we know that whenever we are asked to calculate the amount of heat developed or energy dissipated, we use Joule's law. And according to Joule's law, the equation that is provided is H equals to VIT. That is written here. Okay. Where H is the heat developed, V is the potential difference, I is the current, and T is the time. Now, from the Ohm's law, we know that potential difference V is equals to IR. Here I is 5 ampere and R, that is resistance, is 20 ohm. So the product is 100. So the potential difference is 100 volt. Okay. Now we will just substitute the value of V, I and T to obtain the value of heat. So in place of V, we substitute 100, I as 5 ampere, T is 30, and we get the value of heat as 1.5 into 10 raised to 4 joule. Okay, this can also be written as, we know that 1000 joule is equals to 1 kilojoule. So 1.5 into 10 raised to 4 joule is equals to 15 kilojoule. So the answer to this question is 15 kilojoule. So in 30 seconds, 15 kilojoule of heat is produced in the electric iron. Now moving to the next question. What is the highest and the lowest resistance that can be secured by combination of 4 coils of resistance 4 ohm, 8 ohm, 12 ohm and 24 ohm? So we have to make a combination using these 4 resistors such that the total resistance is highest in first case and the total resistance is lowest in second case. Okay, we know that if we connect these 4 resistors in series, okay, if we are going to connect all these 4 resistors in series, we will get the maximum value of total resistance. So to obtain the solution of the first question, that is the highest amount of resistance that can be obtained from this combination, is we will just add these resistors to get the value of highest resistance, because in series combination the equivalent resistance is just equal to the arithmetic sum of the resistance of the resistors. So here we have the highest value of resistor as 4 plus 8 plus 12 plus 24 ohm, that is 48 ohm. Now to obtain the value of lowest total resistance, we will connect all these 4 resistors in parallel. Okay, so the equivalent resistance that is connected in parallel, and we have the formula to calculate the equivalent resistance in series in parallel is 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Okay, just rearranging, we get the value of R equals to 1 by 1 divided by 1 plus R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Okay, and the value obtained is 2 ohm. So the lowest value of resistance, total resistance that can be obtained from this combination is of 2 ohm, right? Now moving to the next question, that is the third question. This question is from the chapter light. The question is, why do we prefer convex mirror as a rear view mirror in vehicles? So we have observed that in vehicles there is a mirror which is used for the purpose of having a rear view of vehicles, okay, to know the positions of vehicles which assist the driver. Okay, so the mirror that is used in manufacturing of that rear view mirror is of convex nature. So the question is, why not concave nature? Why don't we prefer concave nature? Why do we prefer convex nature? Okay, so the solution is convex. We prefer convex mirror because of its property, and the property is that it provides a wider field of view, so that it gives you a wide area of view. So this will facilitate the driver, and it gives a wider angle of view. Okay, the second reason is convex mirror always forms an erect, virtual, and diminished image. Okay, so it is not going to produce a non-erect image, a real image which needs a screen to be produced, and it also produce diminished image. Okay, so these are the reasons we prefer a convex mirror over a concave mirror, which is not going to produce an erect image, which is not going to give a virtual image all the time. Okay, that is why we are preferred convex mirror in rear view mirror of the vehicles. Now moving to the next question. This is also from Ncert textbook. A convex lens forms a real and inverted image of a needle at a distance of 50 centimeter from it. So the image distance, that is object image of the object, is formed at a distance of 50 centimeter. Where is the needle placed in front of the convex lens if the image is equal to the size of the object? Also find the power of the lens. So the position of the object should be at a distance of 2 times the focal length. Okay, since the image is the real and same size. Okay, so it is given that the image of the needle is formed at a distance of 50 centimeter from the convex lens. Therefore the needle should be placed in front of the lens at a distance of 50 centimeter. Okay, so the answer to the first question is the object should be placed at a distance of 50 centimeter. Now moving to the next part of the question, that is find the power of the lens. We know that the power of the lens is inverse of the focal length. So to obtain the power of the lens, we have to first calculate the focal length of the lens. For calculating the focal length of the lens, we will use the lens formula. Here we have the values of object distance as minus 50 centimeter, because the object is placed at the left of the lens, image is found at the right of the lens. We are going to be very cautious about the sign here, and we will put the value along with sign. So object distance is minus 50 centimeter, image distance is plus 50 centimeter, focal length we are assuming here as f. Now according to the lens formula, we have 1 by v minus 1 by u is equals to 1 by f. So 1 by f is equals to 1 by 50 minus 1 by minus 50, because u is minus 50. So we are getting value of 1 by f equals to 1 by 25. We are getting the value of 1 by f as 1 by 25. So f is equals to 0.25 meter, right? So the power of the lens will be equals to p equals to 1 by f, as we already talked about this, and 1 by f is equals to 1 by 0.25 equals to plus 4d, where d denotes the diopter, that is the unit of the power. So the power of this convex lens is 4 diopter. Now moving to the next question. Name two safety measures commonly used in electric circuits and appliances. So this is a very simple question, but there is a idea or concept behind this that we need to understand. The safety measures that we commonly use, there are a lot of safety measures. Like here we have just named two safety measures as fuse and earthing. We also have RCC, RCB, MCCB. Okay, so you already have studied about these things from the textbook. Now name two safety measures commonly used in electric circuits and appliances. So the first thing, that is fuse. Okay, this is very important part of electric circuit, and why we are going to use fuse? Because of its function. Okay, and what is the function of fuse? See, when each circuit should be connected in fuse, because a fuse prevents the flow of excessive amount of current through the circuit. Okay, so obviously when in any case if there is an excess amount of current passing through the circuit, then the appliances connected in the circuit is is going to be is going to face short circuit. Okay, it is going to fail, right? So the bulbs, the refrigerators, which is a part of the electric circuit. Okay, so to prevent the failure of the electric appliances, we are going to use fuse. So it will prevent the excessive current. Okay, and how does it prevent, how is it going to prevent the excessive amount of current? So when the current in the circuit exceeds the maximum limit, okay, when the current in the circuit exceeds the maximum limit of a fuse element, the fuse melts to stop the flow of current, protecting the appliances connected to the circuit. So in the electric circuit, the wire that we are going to use in the fuse is of a lower melting point as compared to the wire of electric circuit. Okay, so when excessive current will flow through the circuit, so it is going to pass through the fuse as well. So the wire in the fuse will melt earlier. Okay, and on melting it will disrupt, it will stop the flow of current. In this way it is going to protect the appliances when excessive flow of current will take place. Now the second thing is by providing earthing. So earthing protects the user from electric shocks. Any leakage of current in an appliance is transferred to the ground by earthing, and the people using the appliance is prevented from getting electrocuted. So what does it mean? Okay, so we have seen that in electric the sockets that we are using in the boards, we have three pins. The one is for the live wire, second is for neutral, and third is provided as a provision of earthing. Okay, now this earthing the wire the appliance is connected to this earthing wire. Okay, also, now whenever in any case, suppose we are taking an example of refrigerator. Okay, in case of refrigerator, if if some wire is attached is got in comes in contact with the body of the refrigerator, then the body of the refrigerator will be at a potential of what we receive in our house, 220 volt. So when a person touches it, he or she is going to get a shock. Okay, so the provision of earthing is provided because earthing wire is connected to the is attached to the body of the appliance. So whenever such things happen, when the current over the body comes, then it is going to pass through the entire current will pass through the earth wire, because it is at a zero potential, right? So in this manner, the any leakage of current in an appliance is going to transfer, because earth wire is connected to the ground. So excessive current will pass through the uh, ground, and the people and the person touching the appliance will not get any shock. So these are the two important safety measures that we use in electric circuits.